So hi everyone, and welcome to our second Gremlin office hours, how to find Kubernetes reliability risks with Gremlin. Some quick notes before we get started. This is an interactive webinar. We want to hear from you as much as you want to hear from us. So please feel free to enter any questions you have into the Q&A panel or even just the chat. Also, feel free to just hang out in the chat channel, say hi, let us know where you're watching from and what takeaways you'd like to get from this session. After the presentation, we will be opening it up. So if you want to ask a question out loud or offer any additional thoughts or input, let us know if you have any Kubernetes reliability experiences. I'm sure we all have had them. Feel free to unmute yourselves then. Also, this webinar will be recorded. The recording will be made available after the webinar. And if you weren't aware, Office Hours is a monthly series. You can see and sign up for future sessions at gremlin.com/office hours. We'll be covering a bunch of other topics related to reliability, so be sure to check that out. Also, I'm Andrew Newman. I'm a senior reliability specialist here at Gremlin. I'm joined by Dan Muret, senior solutions architect. We're here to answer your questions, so again, don't be shy. Let us know what's on your mind. So just to go over a quick agenda, what we have planned for today, I'll start with a short presentation introducing the topic. I'll talk about what detected risks are and how they show up in Gremlin, focusing specifically, of course, on Kubernetes risks. Dan will run us through a demo showing how to find and fix these risks. And then again, we'll leave time at the end for open Q&A. So I like to start these sessions by setting some goals. First and foremost, we want to be able to check a Kubernetes service against a list of reliability risks. That's kind of the whole idea of this session, is to be able to see which risks are present in our Kubernetes clusters. So this is going to be our key goal. Second, we of course want to make sure that we mitigate those risks and that we have a way of detecting those mitigations so that we can prove that we've resolved these issues. And then we want this process to be automated so that we can run it and repeat it on any new pods or deployments that we send out in the future. Of course, these are just the goals that we came up with. If you have goals or takeaways that you'd like us to cover or that you'd like to get from this session, again, let us know. So let's kind of start with the basics. What is a detected risk? So basically, a detected risk is something in your Kubernetes cluster that puts its reliability at risk or that threatens its reliability. So for example, do you have a failed container somewhere? Is one of your pods stuck in a crash loop? Did one of your control plane nodes go offline? Did you forget to add a liveness check to one of your deployments? All of these can cause reliability issues, if not immediately, then definitely down the road. And so we want to aim to detect as many of these as we can. These risks then get surfaced in Gremlin's web application, so you can take a look at each one, check whether your deployments are at risk, and make improvements. And we'll go over the full list of those risks later, so don't worry. I just wanted to give you a general introduction to the concept and how it appears. So the way it works in Gremlin is pretty straightforward. Basically, if you're familiar with Gremlin already, then you know about deploying the Gremlin agent. For Kubernetes, our agent is available as a Helm chart, and it runs as a daemon set so that we run exactly one instance for each worker node in your cluster. You can also run it on your control plane nodes, and you can be able to test the reliability of those as well. We support tolerations, so you can control which nodes it runs on in case you don't want it to run on certain ones. And the way our agent works is that it can access the Kubernetes API, but it's read-only. We're not interested in modifying any part of the cluster or reading secrets or anything like that. All we're doing is evaluating the configuration and seeing which services that you're using that you've added to Gremlin, how they're configured, and if there are any risk inherent in them. So like, for example, Gremlin can see the deployments and the namespaces running on your cluster, but it doesn't know their details until you go into the Gremlin web app and then add one of those deployments as a service. That's when we go in deeper and see, which pods make up the deployment, which containers are running inside those pods, which hosts they're running on, and so on. All of this feeds back into the detected risk system. And so knowing this stuff, we compare your service's configuration against the rule set that we've created for these detected risks, and then store the results. This is simple JSON. We're just doing comparisons, basically. But this tells us basically, what we need to know about the pods and deployments so that we can determine whether or not there's a reliability risk that's present in it. So don't worry, this graph looks complicated, but it's not. It's just a walkthrough of the risks that we cover. And we split them into areas to make it a bit easier to explain them. So we have pod level risk, deployment level risk, and then cluster risks. So for pod level risks, we cover things like if you use init containers, we look to confirm that they finish successfully. Init containers basically run before the main container does. It does some setup processes, like, for example, pulling data or creating files. If this fails, the main container won't start. So we want to check to see which of these init containers have failed so you can go fix them and have your main containers running successfully. Next is non-uniform application versions. Basically, this means that if you have multiple replicas of your pod running, we look to make sure that they're all using the same image version. And yes, this means no using the latest tag. That's something we've all done. It's the easy, straightforward option. But the problem with using a dynamic tag like this is that the image can get updated. So for example, if you deploy a pod and then you wait a day or so, and then you deploy another instance of the pod, that container image could have been updated on the back end. So you could have multiple different versions of the same software running on your cluster, which can lead to all kinds of conflicts and troubleshooting headaches. So we recommend avoiding it altogether and just pinning your image to a specific version or tag. And a classic, we look for image pull back off and crash loop back off errors. This is basically when you have some bug or issue in your container manifest or image registry preventing you from running or even just creating the pod to begin with. Crash loops are usually caused by the software inside the container not starting up properly, while image pulls are usually caused by the node not being able to reach the registry where the image is hosted. In both cases, you'll want to check the pod logs and pod definition to see what errors were logged. Jumping to deployment level risks, we look to make sure that you set memory requests and also limits. This is to make sure that your pods have enough memory to run and are scheduled onto nodes with enough capacity. The limits are there to prevent memory leaks and, of course, to prevent overzealous pods from using more memory than they should have access to. We also look to see if you set CPU requests for basically the same reason. This is making sure that your pods have enough resources available to run properly. Kubernetes uses its scheduler and factors in a ton of different variables, including CPU requests, memory limits, and so on, to figure out which node is best suited to run this pod. Without it, it's more or less a best guess. So let's give it as much information as we can so that it can make the best choice. Then we also look to see if you have liveness probes enabled. This is so that if your pod becomes unresponsive, Kubernetes can automatically restart it for you. Otherwise, you'd have to manually go in and restart the pod yourself, or just have something like K9s open in a separate terminal, which, again, why go through that manual effort when you can have Kubernetes do it for you automatically? So that's why we factor that in as a risk. And looking more at a high level for cluster level risks, we check for AZ redundancy. This is basically ensuring that your cluster has nodes in at least two different zones. This is so that if one of the zones becomes unavailable, you still have some nodes to fall back to. And yes, this does happen even in major cloud providers. I won't name them, but I'm sure you have an idea of which ones I'm talking about. They might have impacted you personally. The nice thing is that managed Kubernetes services will often abstract away the control plane nodes so that you only have to worry about the worker nodes. But if you do manage a cluster yourself, or even if you have a cluster with, some pretty critical applications running on it, and you want to make sure that it remains available no matter what, you can use this check to just very quickly take a look and make sure that your cluster isn't susceptible to it. And the way we check this is pretty straightforward. We just look to make sure that your cluster has at least two unique zone tags attached to it that's reporting back two different zones. And then lastly, unschedulable pods is exactly what it sounds like. We look for any pods that can't be scheduled onto a node. And while this might sound like a pod risk up front, not being able to schedule pods is almost always a problem with the cluster itself. It can be due to maybe it can be due to maybe you've run out of capacity. Some of your nodes have failed, which caused your cluster to exhaust its available capacity. Maybe you have misconfigured taints or tolerations, or could be any number of reasons. Kubernetes is a really complex system. It's often hard to tell what exactly could have caused the issue. But this is just a way to determine that there is an issue and get you on that first step towards resolving them. I know we covered a lot. We have a bunch of detected risks in Gremlin. Honestly, one of the best ways to get a better sense of what we look for and how we address them is to check our documentation or jump into the product itself. We also provide a full description and rationale for each of these risks within the product, so you have that quick, easy access to it. In the meantime, though, I'm going to turn it over to Dan, who's going to show us a demo of how this works.
Thanks, Andre. I will share my screen or my tab. All right. So to kind of show the detected risk, once you add a service to Gremlin, whether it's via an annotation or manually adding the service into Gremlin, it'll show up here. It'll automatically scan your manifest, your configuration to look for those detected risks. So if we look at this, this is a simple banking application that I have in this cluster. So if I look at my balance reader, for example, I can see a few things right off the bat. So I've ran the default Gremlin test suite. So it's ran these tests, but my score for my reliability is only setting at 70%. So part of that is if I look at this, we're not able to run the zone redundancy test because if I try to run this, it's going to tell me you've only got a single zone. So if I block that zone, it's going to cause an outage. So Gremlin will stop you from intentionally causing an outage on your deployment. We can also see that by looking at the detected risk. So if I click on the detected risk, here's the list of risk inside of Gremlin. We can see I've got an AZ redundancy risk. I don't have a memory limit. I don't have a CPU request. I don't have a liveness probe set. So I've got a few risks on this service that is impacting my score, right? Because I'm only getting 20 points out of a possible 25 on this, and the rest of this is really coming from that zone test. So what I can do is by looking at this, like Andre mentioned, I can look at if I click on these, it gives me some information. Why is, AZ redundancy a risk? And how do I fix that? So what I've done to kind of make this simple on the back end is I basically have a script that I'm going to kick off that is going to basically update my deployment. It's going to add these types of things in it. So I'm going to scale this from 1 replica to 3. This is an EKS cluster, so Amazon is going to be nice enough to handle the AZ distribution for me. It's going to schedule it across different AZs. I'm also adding in memory limits, CPU requests, liveness probes, all that kind of good stuff. So basically what I'm doing is I've kind of automated the steps that you might have to do to address these as well. So if we go and I refresh my page here, we'll see if these come back up. So now that I've updated my configuration, I updated my deployment, I've scaled this up to multiple zones. So the zone redundancy has been taken care of. I've added my memory requests, my limits, all that good stuff. So everything looks good now. So if I go back, I can see my score jump from 70 to 83%. And now I can also kick off this zone redundancy test. It's going to test, the failure of that zone to make sure that it all works as planned. If one of these random zones that we pick is not available, it'll go ahead and do that for us. So it's going to run that test. This test takes about 5 minutes. So depending on how this test runs, while we're evaluating this against our health checks, my score could potentially jump up to 100% on that. One other thing I thought I would mention on this, since we're kind of talking about detect risk, this is a new feature that just came out like this week in Gremlin, is there are instances where you may or may not want all of these detected risks to be evaluated. Keep in mind, this is a passive validation. It's not doing any types of experiments or anything. It's just a notification method based off of your configuration. But through the test suite scenario, or the test suites, you can set up, and if I basically just say, I want to edit my test suite here. So if let's just set up a new one real quick. We'll just leave it cloned. And if I leave this the same, just to show this screen here allows me to include or exclude detected risks. So if this is a completely on-prem deployment, maybe AZ redundancy doesn't apply. Maybe I don't want it evaluated, even though we can set this up and we can definitely simulate the zone failure in an on-prem environment. If I don't want this automatically evaluated by Gremlin, I can add this to the category that says risk that will be ignored. And then when I apply this test suite to my services, we'll evaluate the remaining 9 detected risks. So we do have ways to customize this. This is a new feature, so I thought this would be a good time to kind of highlight and show how this works. If you haven't looked at test suites, you can definitely dive deeper into that. in the future, but there is a way now to customize this as well. So with that, we will pause, wrap up the demo portion, and we can open it up for Q&A or any other questions.
Cool. And really quickly before we do that, or while we're waiting for questions to roll in, pull up my screen. Just in case you're wondering how you can get into this, first, like Dan showed, if you're a current customer, just hop right into the product. Everyone has access to this. So you can head over to the services screen and just check to get started with that and see which one applies to your service. If you're not a current customer, you can start a free trial at gremlin.com/trial. Again, this will be made available to you as soon as that trial starts, so you can check that out. And then again, this is going to be a monthly session. So if you found this valuable, we'd love to see you in one of our future ones. You can always check out our future sessions at gremlin.com/office hours. And while we have some topics listed, we're really interested in knowing what you want us to talk about. So if you have a topic in mind or something you're curious about, let us know, paste it into the chat, send it to us over our contact form or over email, let your sales rep know. Basically, just get the word to us and we'll see if we can do a session on that. And then one last thing, if you want to look more into detected risks, but aren't able or don't want to jump into the product, we do have it available fully on our documentation site. So if you go to gremlin.com/docs, you'll see detected risks on the left under reliability management. And we have a full breakdown and also a video of how it works there. So you can get a sense of how it works there too. Now, like Dan mentioned, we'll be hanging out, and if you have any questions, feel free to submit them. So we had one come through. Can you please talk one more time about pod risks associated with non-uniform application version? So yeah, basically the idea behind that is when you're running multiple pods within your cluster, sorry, I was clicking on the wrong one. When you're running multiple pods within your cluster, the assumption that Kubernetes makes, and this is true for containers too, is that the image that you're using as the basis for those pods and the containers running in those pods is the same. So for example, let's say you're deploying a web server like Nginx to your cluster. You want to have different instances of Nginx running as you scale up or scale down or having it run on different nodes, whatever it might be. You can specify which version of Nginx to deploy. So that way, you know for a fact that each of those instances is running the exact same version. Now, let's say Nginx comes out with a new version, like version 2.0, for example. If you have a tag set on your cluster or on your pod manifest, then even if that upgrade comes out, you're still running the same version of Nginx, right? It's still pulling that same old image version. But if you're using a tag like latest or even something like stable, what that means is that that will track whatever the latest version is. So if Nginx sends out their shiny new 2.0 version and you're using a dynamic tag, there's a chance that if you deploy a new replica, it will pull that new version down and run it alongside your existing versions. So while that might not be terrible upfront, you can imagine if Nginx 2.0 deprecated a feature that you're using or changed the way configuration files work or have a performance problem or have some serious whatever it might be, the behavior is different and it'll be really hard to track that down because on the surface it looks like all those replicas are the same. So that's why we check to make sure that your images are all using the same version as long as they're part of the same deployment so that you don't have issues like that coming around. And then another question is, I was curious to know as to what are the various faults specifically against Kubernetes that Gremlin offers. You've come across products that have faults that can be triggered against Kubernetes core components. Does Gremlin offer that kind of capability for Kubernetes? So the short answer is that basically all of the faults that we have available in general can also run on Kubernetes, except for, I think, time travel, which changes your system clock. And, it works on various levels as well. So you can run a fault against a individual pod or an individual container within a pod. You can run a fault across your entire deployment, or if you have a daemon set, you can run a fault on that as well. And you can also run faults on individual nodes too. So for example, if you want to make sure that your managed Kubernetes cluster can automatically scale if one of your nodes goes down, you can run a shutdown or black hole fault, which drops all network connections to that node, and check your cluster to make sure that it scales up. So if you do want to get a full view of all the different faults available, you can go to our experiments list under fault injection. We have three main categories: resource, which of course consume resources like CPU and memory; state experiments, which change the state, so you can shut down a pod or terminate the processes running within it to make sure that it automatically restarts; and then network experiments, so you can drop all network traffic. If you have TLS certificates that you're using within your cluster, you can check to see if any are expiring soon. You can add latency, packet loss, and then simulate a DNS outage if you have a fallback DNS server for that as well. And again, these can rerun across all of the different layers of your Kubernetes deployment: individual pods, containers, deployments, and also nodes.
And I can chime in with a kind of another example on that one too. So I was working with a large telco provider this week, and they actually installed Gremlin on their worker nodes. They also installed Gremlin on their master nodes. They run Kubernetes on-prem. They had 5 master controller nodes, and then they had, I think, 16 worker nodes in this particular environment. They are trying to build this as a provisioning system for 5G. And so they were wanting to test master node failures without having to go to the data center or go into the virtualization system to disconnect the network. So they use Gremlin to basically black hole 1, 2, 3, 4 master nodes to see what the impact is to their cluster. So they're testing the resiliency of their cluster by black holing the master, the control plane nodes to see what the impact is. So yes, we can definitely do different levels of tests, specifically around Kubernetes, the function, the interoperability, whether it's black holing and affecting scheduling and availability. Maybe it's consuming CPU, which could impact your scheduler. If you're consuming a lot of CPU resources and you have a request for a new deployment that needs X amount of CPU, does your scheduler see that? Does it, schedule on the right node, or does it not schedule at all because of that? Maybe you need to adjust your auto scaling policies, those sort of things. So there's a lot of tests you can really do at that Kubernetes level to really exercise and make sure that it's as resilient as you need it to be or as you want it to be.
Good question. We have another one. Can we see or track risk for a specific team or across multiple teams? Yes, actually. So in Gremlin, we have, sorry to steal your thunder, Dan. I just happen to have it open in the background. We have different reports that you can view to basically just see where your reliability stands. And one of these is the team risk report. So for example, my team, I'm really terrible about addressing risks. So you can see that I have a lot that I need to look into. But this just gives you a high-level overview of where your Gremlin team currently stands on their risks. So you can see I have a bunch of risks or a bunch of services in my team that are generally doing pretty good, but they're really bad at zone redundancy and liveness probes. So based off of this, I know that I need to go back into these services and make sure that they're set up for redundancy. Maybe the cluster that I use needs some zone redundancy enabled on it or configured on it. And then I need to go back in and create these liveness probes. The other nice thing about this report is that you can change teams just by using this dropdown. So if you want to see how like your entire department or engineering organization as a whole is doing, you're able to jump between those as well. We also give you the ability to export this as a PDF. So if you're old school and like handing a physical report to somebody, you can do that too. And as another quick mention, this is also factored into some of our other reports, including our company summary report. So this one will also show you the number of risks that your entire company has had over time, not just your specific team. This is another good, really high level view just to be able to see where your stance is as like an engineering organization, to know how many risks in general your systems have. Also, ignore my company score. This is a demo environment. See, what kind of privileges are required to run these experiments? Do we need admin privileges to run these experiments? So We try to use as few permissions as possible. We actually explicitly list out which permissions we require in, I want to say, our security page. So within the container we run, we do require root access, but we have also specific system privileges that we request. And these are documented in our security page. If you want to see exactly what those are, you can come here and we list those out. But as far as actually deploying it, as long as you're able to deploy a Helm chart or a Kubernetes manifest to your Kubernetes cluster, that's basically the minimum we require to be able to deploy our agent. I don't know if you have any more deeper insight into that, Dan.
Yeah, I mean, it kind of varies on what you want to do, right? I mean, if you're wanting to black hole a master node, for example, yes, that's going to require, elevated privileges, root privileges, whatever you want to call it. If you're wanting to, but on the flip side of that, you can also, through Gremlin's RBAC, you can lock this down to where a team can only run experiments on a deployment in a given namespace. So you can lock it down to where, so it really depends on what you want to test and how you want to set that up. So Gremlin deploys that, you basically need root privileges to deploy it. We create a Gremlin role and cluster role binding on the cluster. But then through our RBAC, you can lock those down to where, users can only do what you want them to be able to do. So yes, it requires some root privileges, but depending on the experiment, you can configure that to where people can or may not be able to do that, just depending on your use case and your environment.
I don't see any other questions yet, but again, we'll be hanging around for a few minutes. So if you do have a question that comes up, definitely let us know. Here's one. Do we have to manually declare a region or zone tag when adding a service, or does the Gremlin agent take care of that automatically? The Gremlin agent will try to look for a region or zone tag, especially if we're deploying to a cloud service like AWS. We are able to detect that automatically. If that's not the case, or if you want to specify a custom region or zone tag or a custom any tag, you're able to do that through the agent's configuration file. I'm trying to think if I have an example of that. I don't think I have an example in my environment, but it will show up as a tag.
Look under
If
agents, Andre, and it should
okay,
show it there.
yeah. So this was a AWS EC2 instance that I was running.
Yep, and there's your zone tag. It's usually the last one in the list.
Yep.
Yeah, so the cloud environments that exist, we'll pull that in. We'll read that from AWS, Azure, GCP. So you'll see a zone tag that has US East 2A, 2B, 2C, depending on how many regions are in that particular zone. If this happens to be like an on-prem deployment, right? So you're running this in 3 data centers that you run, zone tags may or may not be there, probably not there. But you could add a zone tag, and it doesn't have to be a US East 2A. This could be a data center name or a data center name, in a row in a rack location. It could be anything as long as it's a zone tag. So the zone is what we're looking at. You can add this, and so I've got customers that would, set this up, and they'll add a custom tag that says, zone is, data center 1, row 1, rack 3, rack 4, and rack 5. So they can block traffic to that specific rack. All we're really doing is looking at that zone tag as an identifier to do that. So we'll pull it if it's there from the cloud provider. If it's, an on-prem cluster, you can add those manually and still simulate the same effects.
Any more questions? I'm not seeing any others come through. If you do end up thinking of a question that we weren't able to answer or weren't able to get to, or we just thought of it right after the webinar ends, you can always reach out to us. Either go to gremlin.com/contact or fill out the form there or talk to your sales rep and be able to ask your questions that way. Just as a reminder, again, these sessions are for you. So if there are any topics that you'd like us to cover in detail, please give us that feedback. We're always excited to hear about what you all are interested in and what we can help you with. So please let us know. Otherwise, again, we'll have future sessions listed at gremlin.com/office hours. So you can go there, check those out. And if you're interested in any of them or they sound interesting, we highly recommend that you sign up. They're all going to be available for free. They're all going to be just like this. So if this session was helpful for you and you're interested in learning more, you can always go there to sign up and hang out with us again. In the meantime, hope this session was really helpful for you. I hope you're able to learn a lot and we were able to answer your questions the way you hoped. Thank you so much for joining us. Again, this is all available right now, so you can use it right away by logging into your account. If you don't have an account, you can head over to gremlin.com/trial to sign up for a free 30-day trial and get started with detecting your risks in just a few seconds. In the meantime, thanks so much for joining us. Hope this session was helpful for you and enjoy the rest of your week.